Everyone, thanks for coming, and today I would like to give you a review of what we have learned in week 1's lectures, the first part of multi-state models. First, we get through several examples of multiple state models. We have the alive-dead model, which is also the simplest model. We only have two states, the alive and death. A lump sum will be paid upon death of the insured life. Next, we have a more complicated model, the accidental death model. So, if the insured life dies as a result of accident, more will be paid than the usual amount. If the insured life dies as a result other than accident of all other causes, then the sum will be paid. So, if the insured life dies as a result of accidents, then the insurance will increase. So we'll have three states: death as a result of accident, and death as a result of all other causes, as well as the alive state. We also have the permanent disability model. So the alive is state 0, the disability is state 1, and death is state 2. So if the insured life becomes permanent disability, the first sum of money will be paid. If the insured life goes to death, then the second sum of money will be paid. So there are two different models that will pay annuity to the insured life upon state change. First, we have the disability income insurance model. So if the insured life becomes sick or disabled, annuity will be paid continuously or monthly when the insured life recovers. We also have the joint life and last survival model. So for the joint life model, the annuity could be paid if both insured life are alive. So this is the annuity for a couple. If one of the insured lives dies, then the annuity will be ceased. We also have the last survival model. The last survival model pays annuity till the death of the last insured life. So this is also used for couples who purchase annuity insurance together. We have some basic assumptions for the multiple states models for the state changes. We assume that the process is Markovian, which means that there's no dependence on past information for the transition probability Pij at any time. For any positive interval of time h, the probability of having two or more transitions within this time period h is OH. So we assume that at any instance there could be at most one state change. Finally, we assume that the transition probability Tpxij is differentiable with respect to time t. The probability of staying at the same state Tpxii is e to the power minus integration of the summation of all transition probability that goes out of I. Also, for the Markovian property, we can decompose the probability that the insured life stays at time x for the time interval t plus h to be the probability that the insured life stays at time state x, state I for time t times the probability that the insured life stays at this state I for another time h. For the permanent disability model, we can differentiate the probability, the state change probability Tpx01. We have Tpx01 dt plus T px01 mu x plus t1, the state change from probability from 1 to 2 equals to t px00 times mu x plus t01. So this is incoming probability density from alive to permanent disability. Thanks for listening.